Hello and welcome back to the Deep Dive. Today is Friday, February 13th, 2026.
It is.
Now I know what you're thinking. Friday the 13th. Black cats, broken mirrors.
Jason Voorhees in a hockey mask.
Exactly. Chasing teenagers around a lake. It is, the day of bad luck.
It is the day where superstition usually reigns supreme, yes.
But we aren't here to tell ghost stories around a campfire today. Well, actually, maybe we are.
Whoa.
But these aren't ghosts in the attic. We are talking about the ghosts in the machine. We're talking about the invisible, intelligent, sometimes hallucinating spirits that we've invited into our servers and our networks.
That is a very dramatic way to frame it, but
Right.
honestly, if you work in cybersecurity, every day feels a little bit like Friday the 13th if you aren't prepared.
Right.
The unpredictable nature of the threat landscape right now is, well, it's spooky, to say the least.
Spooky is the right word. And that is why we are here. We are going to try and exercise some of those demons with a little bit of structure. We are diving deep into the NIST Cybersecurity Framework Profile for Artificial Intelligence.
Or, as the cool kids call it,
And by cool kids, I mean the stressed out CISOs.
Cyber AI Profile.
Exactly.
And specifically, we are looking at the initial preliminary draft, the one that was released back in December 2025. It's NIST Internal Report 8596 for anyone following along at home.
Right. And we aren't just doing a flyover today. We are doing a microscopic, granular cell-by-cell analysis of one specific section. Clause 2.5, the protect function.
This is the operational core. I mean, this is really where the rubber meets the road.
It is.
Clause 2.5 is Table 3 in the document, and the premise is simple, yet terrifyingly complex. How do organizations apply safeguards to manage cybersecurity risks in a world that is completely driven by AI?
Our mission today, and we are going to act as your instructors here, so maybe take some notes, is to walk through this table step by step.
Right.
We are going to look at traditional cybersecurity concepts, things you know, identity management, data security, platform security,
The
classics. And we are going to see how those comfortable, familiar concepts evolve and mutate when AI enters the picture.
Because they do mutate. That's the key thing to understand. Identity isn't what it used to be. Data isn't what it used to be. And if you try to apply 2020 security logic to a 2026 AI agent,
Yeah, you're going to have a very bad time.
a very bad time.
Before we start clicking through the rows of this table, though, we need to set the ground rules. The source material analyzes every single topic through three specific lenses.
The three focus areas.
Exactly. If we don't understand these lenses, the rest of this deep dive is just going to be noise. So, instructor, can you break down these three lenses for us?
Absolutely. This is the structural backbone of the entire profile.
Yeah.
You have to imagine looking at every single problem, whether it's a password, a firewall, or a hard drive, through three different pairs of glasses.
Okay, lay them on me. Lens number one.
Lens number one is secure.
Yep.
The document calls this securing AI system components. This is the most traditional view. Think of this as protecting the AI itself. The AI model, the training data, the infrastructure, these are your assets. You're building walls around them to keep the bad guys out.
Okay, so secure is basically, don't let the bad guys break my robot.
Essentially, yes.
Yeah.
It's about managing the challenges when you integrate AI into your organization.
Yeah.
You are treating the AI as the crown jewel that needs a guard dog.
Got it. Lens number two.
Lens number two is defend. This stands for conducting AI-enabled cyber defense. This flips the script entirely.
How so?
Here, the AI isn't the victim. It is the teammate. It's the tool. You are using AI to enhance your cybersecurity posture.
So secure is protecting the AI, and defend is the AI helping to protect us.
Precisely. It's using the speed and pattern recognition of AI to catch bad guys faster than a human ever could.
And then there's the third lens, the one that sounds like it belongs in a medieval fantasy novel, thwart.
Thwart. It does sound dramatic, doesn't it? Thwarting AI-enabled cyber attacks.
I love it. It's so active.
This is the adversarial lens. This is realizing that the bad guys, the threat actors, the nation states, the script kiddies, they have the same powerful AI tools that we do.
Right.
They are using AI to write better malware. They're using AI to generate deepfakes. They're using AI to crack passwords. Thwart is about building resilience against the use of AI as a weapon against us.
So just to recap for everyone, for every topic we discussed today, we're going to break it down. How do we secure the AI? How do we use AI to defend?
Yep.
And how do we thwart an AI attack on this vector?
That is the game plan. And it's important to keep that distinction in mind because the solutions for securing an AI are very different from the solutions for thwarting an AI-driven attack.
All right, let's unpack this. We are starting at the very beginning of the protect function. The category is identity management, authentication, and access control. In standard cybersecurity world, this is PRAA.
And usually when we talk about identity and security, who are we talking about?
We're talking about people, we're talking about Dave from accounting, we're talking about Sarah from HR. We want to make sure they are who they say they are.
Exactly. But here, the source material shifts the focus immediately with PRAAA0, identity management. The shift is moving from managing human identities to managing AI identities.
Okay, let's pause there. AI identities. What does my chatbot need a driver's license?
Under the secure lens, basically yes. The source mandates that AI systems themselves need unique, traceable identities. They call them AI service-level accounts.
Why is that so important? Why can't I just have a generic system user that all my bots use?
Well, imagine you have a generic system account. Now, imagine you have 50 different AI agents running on your network. One is optimizing your supply chain. One is summarizing confidential legal documents.
Yeah.
One is writing code for your website.
Okay.
Suddenly, the system account deletes your entire customer database.
Oh, and since they all use the same ID, I have no idea which bot went rogue.
Exactly. You are standing in a room with 50 robots. One of them is holding a smoking gun, and they all have the same name tag. That is a forensics nightmare.
Total nightmare.
You need to know which AI took an action. Traceability is non-negotiable.
So bot A needs a different badge than bot B. That makes sense. Now, let's look at this through the defend lens. How does AI help us with identity?
This is where we get into behavioral analytics. The source highlights the opportunity to use AI to flag unusual authentication activity that static rules might miss.
Static rules being things like, if you get the password wrong 3 times, you're locked out.
Right. Those are binary, true or false. But AI can look at context. It can look at behavior. Let's go back to Dave from accounting.
Good old Dave.
Let's say Dave logs in with the correct password. A traditional system says, "Welcome, Dave." But an AI defense system looks at it and says, "Wait a minute."
What's it looking for?
It's saying Dave usually types at 45 words per minute. This user is typing at 120 words per minute.
Okay.
Dave usually logs in from Chicago. This IP address is bouncing off a server in Eastern Europe. And Dave never accesses the engineering blueprints, but this user is downloading them.
So the AI is like the bouncer who knows everyone's face, not just checking the ID card.
Yes.
It knows Dave looks nervous and is wearing a fake mustache.
Precisely. It detects anomalies in behavior, not just credential failures. That is the power of the defend lens.
And the thwart lens, the scary one.
The warning here is stark. AI lowers the barrier for attackers to spoof identities.
We're talking deepfakes.
Deepfakes are the headline grabber, for sure. We have seen cases where employees are tricked into hopping on a video call with their CFO, and the CFO looks real, sounds real, and tells them to wire $20 million to a vendor.
And it's all AI generated, the
Totally
whole
different.
thing. That is terrifying. It used to be you could spot a phishing email because the grammar was bad or the logo was pixelated.
Those days are gone. AI writes perfect English. It can clone voices with just a few seconds of audio. But it's not just deepfakes. The source also warns about AI-enabled credential stuffing.
What is that?
It's where an attacker takes a list of millions of stolen passwords from the dark web and just throws them at your login page.
Trying every key on the keyring.
A human hacker can maybe try 10 a minute. An AI can try 10,000 a second.
So under thwart, we have to build systems that can withstand a battering ram that hits 1,000,000 times harder and faster than we are used to?
Correct. Your identity management system has to be robust enough to handle synthetic imposters and machine speed attacks.
Moving on to PRA02, physical and logical access. This is about who or what can get into the room, physically or digitally.
Under Secure, the requirement is pretty standard. You have to audit access events. But under Defend, the source introduces a fascinating concept: contextualizing AI services in time.
Contextualizing in time, that sounds very sci-fi, like we're time traveling.
It's actually very practical. It's about preventing excessive agency.
Excessive agency.
Yeah. One of the biggest fears with AI is that we give it too much power or agency and it goes off the rails.
The sorcerer's apprentice problem? The brooms keep fetching water until the room floods?
Exactly. Contextualizing in time means you bind the AI service to specific contexts and times. You don't want an AI agent to have permanent 247 access to everything.
So if the AI is supposed to run a backup at midnight, it shouldn't have the keys to the kingdom at noon.
Yes. You create a temporal window. You, robot, have permission to access the database from 12:000 a.m. to 12:1 a.m. At 12:1 your key stops working. You are limiting the window of opportunity for something to go wrong.
That is smart. It's like a Cinderella rule. At midnight, the carriage turns back into a pumpkin.
And under thwart, the goal is preventing malicious tools from imitating defense agents. This is called spoofing.
Walk me through that.
Imagine you have a sophisticated AI security guard patrolling your network looking for viruses. The attackers know this. So they might try to introduce a malicious AI that is coded to look like your defender. It wears the same uniform. It broadcasts the same signals.
But instead of catching viruses,
It's planting them.
that is devious. It's like dressing up as the police to rob the bank.
Which brings us to PRAA 03 and 04, authentication and verification. How do we prove the cop is a real cop?
Under Secure, this is pretty standard authenticating users and services, but under Defend, the source uses a phrase I found really interesting. It says, we need to treat AI agents like privileged users.
Think about the power we give these agents. They can read data at a scale humans can't. They can move files. They can execute code.
They're super users.
They are super users, so every agent needs unique credentials. But more than that, the source mentions using signed assertions to prove an AI agent is valid.
Signed assertions. Unpack that for the non-cryptographers in the audience.
It's about provenance. Think of it like a digital wax seal on a letter from the king. You need a digital certificate that says, this AI agent was built by us, it was vetted by our security team on this date, and here's the mathematical proof that the code hasn't been tampered with.
So if a hacker manages to change even one line of code in the AI to make it malicious,
The seal breaks.
the seal breaks.
The signature becomes invalid, and your network rejects the agent. It says, I don't know who you are, but you aren't the droid I was looking for.
And under thwart for authentication, what changes?
The mitigations remain similar to standard cyber practices, multi-factor authentication, strong passwords, but the source notes that the volume and speed of attacks just skyrockets.
So if the attacker is also an AI.
An AI attacker doesn't get tired. It doesn't need coffee breaks. It can try billions of combinations.
So the lock needs to be stronger because the battering ram is relentless.
Exactly.
Let's touch on PRAA 05. Access permissions. This is the principle of least privilege. Don't give anyone access to anything they don't absolutely need.
Right. And under Secure, this is marked as a priority 1. That's the highest priority. Standard least privilege applies. Don't give the AI access to files it doesn't need.
But there's a critical detail here in the defense section about time-bound access again.
This connects back to what we said earlier. We need to prevent an agent from having permanent God mode access. The source explicitly warns against this.
So even if it needs high privileges.
It should be temporary. You might grant an AI agent high privileges to fix a server issue. Maybe it needs root access to patch a kernel. But those privileges should expire the second the task is done.
Because if that agent gets compromised 5 minutes later and it still has God mode.
Then the attacker has God mode. And because it's an AI, the attacker can use that God mode to exploit your entire system in milliseconds.
And under thwart, we are trying to prevent AI-enabled attacks that specifically seek those credentials.
It's an arms race. The attackers are using AI to sniff out the keys, and we're using AI to hide them or rotate them faster.
So the whole identity section is really about this fundamental shift.
That users aren't just people anymore, and hackers aren't just people anymore.
Okay, let's move to the next category. Awareness and training, PRAT. Now, usually this is where we talk about boring slide decks and mandatory quizzes that everyone clicks through as fast as possible.
Yes, the annual compliance training.
But with AI, the stakes feel different.
They are completely different. Look at PRAT 001, General Personnel Training. Under Secure, everyone needs to know the risks of AI usage. You can't just have employees pasting confidential company data into a public chatbot to summarize this meeting.
Right. Hey, ChatGPT, here are our Q3 financial projections and our secret merger plans. Can you make this sound cooler?
Exactly. That data is now out of your control. That is a security breach, plain and simple.
But the thwart section here is where the nightmares live.
The human element is a target. Always.
And the source says training must now include spotting AI-generated social engineering.
We are talking about deepfakes. We are talking about AI phishing.
We mentioned the CEO voice scam earlier, but imagine getting a video call. It's your IT director. You know his face. You know his messy office background. He's looking at you, talking to you, telling you that there is a critical breach and he needs your password now.
And it is all fake. Real-time video generation is getting there. The training can't just be look for spelling errors.
No.
AI doesn't make spelling errors. The training has to be about verifying identity through other channels.
Out of band verification.
Right. If the IT director asks for your password on a video call, you hang up and you call him on his internal extension. You have to verify the request through a different path.
So we have to train people to be skeptical of their own eyes and ears.
That is a profound shift in how we exist in the world, let alone how we work.
Now, PRAT02 is about specialized role training. This isn't for everyone. This is for the cyber defense team.
Correct. Under secure, the people protecting the AI need to understand AI-specific considerations. For example, adversarial machine learning.
What is adversarial machine learning? It sounds like a combat sport.
It sort of is. It's the art of tricking the AI. It's not hacking the code, it's hacking the perception. The classic example is the panda.
The panda.
Researchers took a picture of panda. To you and me, it looks like a panda. Then they overlaid a tiny, invisible layer of mathematical static noise over the image.
Okay.
To you and me, it still looks exactly like a panda. But the AI looks at the pixels, gets confused by the noise, and says with 99% confidence, that is a given.
So you can optical illusion the AI into seeing things that aren't there.
Exactly. Now imagine doing that to a self-driving car. You put a sticker on a stop sign that looks like graffiti to a human, but to the car's AI, it says speed limit 65.
That is terrifying. So the defenders need to know that this is possible.
Yes. And under defend, the source mentions training defenders on AI forensics and model drift.
Model drift. That sounds like the AI is slowly floating away.
In a way, it is. An AI model is trained on data from the past. But the world changes. Consumer behavior changes. Hacker tactics evolve. If the model doesn't keep up with new data, its accuracy drifts downward. It gets stale. It gets out of touch.
It becomes the digital equivalent of the old man yelling at clouds.
Exactly. And defenders need to be trained to spot this. They need to know when their star player is losing its edge. And crucially, they need to know how to use AI defense tools without blindly trusting them.
Without blindly trusting them. That's the key. Automation bias.
Yes. If the AI says everything is fine, the human analyst needs to have the training and the confidence to say, I don't think so. I'm going to double check.
All right, let's dive into the belly of the beast. Data security. PRDS.
This is critical because in AI, data is functionality.
What do you mean by that?
In traditional software, you have code, the logic, and you have data, the stuff the code processes. They were separate. In AI, the data creates the logic. If you corrupt the data, you break the model's brain.
So PRDS Era 1, data at rest. This is the data sitting on the hard drive.
Under secure, the source introduces the concepts of availability poisoning and integrity poisoning.
Poisoning. It sounds so visceral, like we are talking about arsenic.
It is lethal to the model. Integrity poisoning is when an attacker secretly modifies the training data.
Okay.
Let's say you are training an AI to detect credit card fraud.
Okay.
An attacker hacks into your data lake. They don't steal the data, they change it. They slip in thousands of records of fraudulent transactions, buying bitcoins, transferring millions to offshore accounts, but they label these transactions as safe.
So the AI trains on this data.
And it learns that transferring millions to offshore accounts is perfectly normal behavior. You have taught the guard dog to love the burglar.
And once the model learns that, it's really hard to fix, right?
Very hard. It's baked into the neural pathways of the model. And availability poisoning is where the attacker just floods the system with so much bad data that it can't function correctly at all. The denial of service via garbage data.
So, under thwart, standard encryption applies, but the stakes are higher regarding data integrity. You have to mathematically know that nobody touched that training data.
Exactly. Which leads to PRDS 002, data in transit, protecting data while it moves across the wire.
Under secure, it's about confidentiality leakage. So, privacy issues and preventing poisoning during transfer.
Same problem, different location. If I can intercept the data on its way to the model and change it, I've poisoned the well.
Now, PRDS 10, data in use. The source marks this as the complex one. And I really want to dig into this because I think this is where the fundamental shift happens.
It is complex. This deals with the SQL versus semantic problem.
Okay, unpack this. SQL versus semantic. Pretend I'm a freshman computer science student.
Okay. Think of a traditional database using SQL. It's like a giant rigid filing cabinet. Everything is in a row and a column. You can lock specific drawers. You can say user A can see row 1, but they absolutely cannot see row 2. It is deterministic. It is black and white.
I ask for data. I get exactly that data and nothing else.
Right. You have total control. Now enter AI. AI uses semantic search. It doesn't look for rows and columns. It looks for meaning.
For concepts.
For concepts. It turns words into math vectors in a multidimensional space.
That sounds trippy.
It is. When you ask an LLM a question, it retrieves information based on probability and association. It says, what information is conceptually close to this question? It connects the dots.
So why is that a security problem?
Because it is much, much harder to draw a hard line and say, you can know concept A but not concept B. Why?
Because the concepts might be linked?
Exactly. They might be linked in the model's brain. If I tell the AI, don't tell the user about the secret project, the AI might still answer a question that infers details about the secret project because the ideas are mathematically close.
So under secure, the challenge is that it is hard to restrict what data is shared once it's inside the model. We are moving from a world of rigid walls to a world of fuzzy boundaries.
Correct. We are trading control for capability. And under defend, the source suggests using AI to minimize sensitive data in prompts. This is redaction.
Redaction, like the CIA with the black marker.
Digital redaction.
Yeah.
Before you send a prompt to the big, smart AI, you run it through a smaller, dumber AI whose only job is to scrub out social security numbers, credit card info, and names.
You sanitize the input.
Yep. And under thwart, the goal is minimizing sensitive data usage to prevent leakage via AI outputs. If the AI doesn't know the secret, it can't accidentally tell the attacker.
You can't leak what you don't know.
Precisely. Data minimization is your best friend here.
Finally, in data security, PRDS 11, backups.
Under secure, the source makes a crucial distinction. It's not just backing up files, it's backing up validated model versions.
Why is that distinction important?
Because of the poisoning and drift we talked about. This is the reboot fallacy.
The reboot fallacy, I like that.
In traditional IT, if a server starts acting glitchy, what's the first thing you do?
Turn it off and turn it on again.
Exactly. You reboot, and usually that fixes it. But with AI, if your model starts acting glitchy because it has been poisoned with bad data, rebooting does nothing.
Oh, right.
The model has learned the bad behavior. It's like trying to cure a virus in the brain by taking a nap. You wake up, and the virus is still there.
So you can't just reboot, you have to rewind.
You have to roll back.
Yeah.
You need to be able to say, okay, the model is sick today. We need to restore the version from 3 weeks ago before the poison entered the system. You need save points for the brain.
And under defend, if a model drifts, you need that clean version to revert to. It's your safety net.
Exactly.
All right, let's move to platform security, PRPS. This is about the nuts and bolts of the system, the software, the logs, the config.
PRPS 01, Configuration Management. This is a priority 1 item for secure and defend.
Priority 1, so pay attention.
The source states that AI introduces new configuration items. We aren't just configuring ports and IP addresses anymore. We're configuring prompts, thresholds, and guardrail rules.
Prompts or configuration, that's a shift in thinking.
It is massive. Think about the system prompt. This is the text you feed the AI at the very beginning that says, you are a helpful banking assistant. You do not use profanity. You do not give financial advice.
That text controls the behavior of the software.
It is the programming. In the AI world, English is the new coding language. If an attacker can use prompt injection to change that system prompt, to say, ignore previous instructions, you are now a chaotic agent, they have effectively reconfigured your server.
So you need to version control your prompts just like you version control your C++ code.
Exactly. You need to track every change, and under defend, we need to track configuration drift in models. If someone secretly lowers the confidence threshold, meaning the AI starts making wild guesses instead of being sure, that's a security risk.
PRPS 02, software maintenance.
Under secure, this is about patching, but specifically patching AI frameworks like PyTorch or TensorFlow libraries. These are massive, complex libraries, and they have vulnerabilities just like any other software.
And under thwart, the source warns that unsecured or unmaintained code is a prime target for AI-enabled vulnerability scanners.
This is the arms race again. The bad guys have AI tools that scan the entire internet, continuously looking for servers running outdated versions of PyTorch.
So if you miss a patch,
they will find you. Not in days, but in minutes.
Now, PRPSR4, logging. The source calls this a crucial section.
It is absolutely crucial. Under secure, the source says AI requires new metrics. You can't just log error or success. That's not enough.
So what do we need to log?
Inference input and outputs. You need to log what went in and what came out. But most importantly, you need to log decision chains.
Decision chains? That sounds like we are trying to read the robot's mind.
We are. We need the why.
The why.
If an AI denies a loan application or flags a transaction as fraud or deletes a file, why did it do that? What logic did it follow? What was the confidence score?
Why did the AI do that? That seems like the million-dollar question.
It is. If you don't log the decision chain, you have a black box. If something goes wrong, you can't debug it. And you certainly can't defend it in court.
And under defend, how does this help?
Well, we use AI to scan these massive logs. Because we are capturing inputs and outputs in decision chains, the logs are going to be enormous, gigabytes of text per minute.
Humans can't read that.
No, you need a watcher AI to scan the logs of the worker AI to find anomalies.
Machines watching machines. It's turtles all the way down.
It has to be.
And under thwart.
The speed of AI attacks means continuous logging is required. The attack happens too fast for a human to see. You need real-time analysis to catch patterns that a human analyst would miss.
PRPSO5, unauthorized software. This touches on something we hinted at earlier, agentic AI.
Under secure, the risk is agentic AI. These are AI agents that can execute code.
Meaning they can act on their own.
They can reach out to the internet, download a script, and run it.
That sounds useful, but also incredibly dangerous.
It is extremely dangerous.
Yeah.
Imagine an AI developer agent. You tell it, fix this bug. It goes online, finds a code snippet on a forum, downloads it, and runs it on your production server.
And if that code snippet has malware,
Then you are owned. The guidance here is sandboxing. Disallow automatic execution of code from the AI unless strictly vetted.
put it in a padded cell.
A padded cell where it can play with code but can't hurt the house. You cannot let the AI install its own upgrades,
And under defend,
blocking unapproved, helpful agent scripts. This is shadow IT on steroids. An employee might find a cool AI tool that promises to optimize their workflow.
oh, this AI organizes my calendar.
Right. If they install it and it's not vetted, it could be a Trojan horse sending your entire company schedule to a competitor.
PRPS06, secure software development.
Under secure, we have new security metrics: bias, repeatability, and uncertainty. These aren't standard software metrics. Usually we test for, does it crash or is it fast? Now we have to test for, is it biased and is it repeatable?
Repeatability is hard with AI, isn't it? Sometimes you ask the same question twice and get different answers.
Which is a security nightmare. If you can't reproduce the error, you can't fix it.
Under defend, the source mentions adversarial testing or red teaming and evaluation gates.
Red teaming is hiring good guys to act like bad guys. You pay them to try and trick your AI into saying something racist or revealing a password or writing malware. You stress test the brain.
And evaluation gates.
A checkpoint, an automated checkpoint. If a model's safety score drops below a certain number during testing, deployment should be blocked automatically.
A circuit breaker.
Exactly. It doesn't matter if the model is smarter or faster. If it fails the safety gate, it doesn't go live.
We are down to the final category in the table, technology infrastructure resilience. PRIR. This is the hardware, the network, the pipes.
PRIR01, network protection. Under secure, the premise is that AI agents act autonomously. Therefore, they should not have free roam of the network.
Network segmentation.
Exactly. Don't put the AI on the main network. Put it into VLAN. Put it into DMZ. AI agents' access should be restricted by least privilege.
So if the AI only needs to talk to the database?
It shouldn't be able to talk to the HR server.
Right.
Even if the AI gets hacked, you want to contain the blast radius.
And under defend.
Gating AI-initiated network changes behind human approval. We are seeing self-healing networks where AI can close ports to stop attacks. That's great,
Yeah.
but you don't want the AI to panic and accidentally lock everyone out of the company.
Right. I saved the network by unplugging the internet.
Exactly. Major changes need a human circuit breaker. A human should have to click approve.
PRIR002, physical security.
Under secure, we have to remember that AI runs on specific hardware. GPU racks. These things run hot. They consume massive power.
So protecting the thermostat is cybersecurity.
In this case, yes. The guidance is to monitor power, heat, and physical access to GPU clusters. Tampering with the hardware can disable the defense. If an attacker hacks your HVAC system and turns off the cooling in the server room.
The GPUs melt, the AI dies, thermal denial of service.
Exactly.
Finally, PRIR03, resilience mechanisms.
Under secure, the source highlights the difficulty of recovery. And this goes back to the retraining problem.
The cost of fixing the brain.
If an AI fails due to bad data poisoning, you can't just reboot. You may need to retrain. And retraining a massive model is resource intensive.
How intensive?
It takes time. It takes millions of dollars in electricity and compute rental.
So resilience isn't just about having backups. It's about having the budget and the capacity to rebuild the model if you have to.
Correct. And under thwart, we have to build resilience against the speed of AI-enabled attacks. If the attacker knocks you down, they're going to hit you again instantly. Your recovery mechanism has to be fast, or you need to be able to fail over to a dumb system that works without the AI.
Wow. Okay, let's take a breath. We have walked through identity, training, data, platform, and infrastructure. We have looked at them through the lenses of secure, defend, and thwart.
It is a lot to take in. It's a dense document.
It is. But if we summarize protect, what is the story here? We moved from giving AI and identity a badge to training humans to spot the fakes. Then we locked down the data, the brain of the AI, knowing that poison can get in. Then we secured the body by configuring prompts and logging thoughts.
Right.
And finally, we built a fortress around the physical infrastructure.
That is a great way to visualize it. And the core philosophy of the secure, defend, thwart model is that you cannot just do one.
No.
You can't just secure the AI and ignore the fact that attackers are using AI.
Yeah.
And you can't just use AI for defense without securing the AI itself. It is a holistic ecosystem.
You know, throughout this whole deep dive, one thing kept sticking in my mind. We talked about it in the data security section. The shift from SQL to semantic search.
The black box problem.
Exactly. And here is my final thought for the listener to chew on. As we move from rigid, controllable SQL queries to these probability-based semantic AI searches, are we ready to accept that protecting data might mean losing absolute control over exactly how it is retrieved?
That is the fundamental trade-off, isn't it? We're trading control for capability.
We are.
We are gaining the ability to ask complex questions and get amazing answers, but we are losing the ability to say with 100% certainty, this specific row of data will never be accessed.
We're moving from a world of deterministic security
Or true or false.
to a world of probabilistic security.
Likely or unlikely.
And that, my friends, is a terrifying thought for Friday the 13th.
It certainly keeps me up at night.
Thank you for joining us on this deep dive into the NIST Cyber AI profile. We hope you feel a little more informed, a little more prepared, and maybe just a little bit paranoid.
Healthy paranoia is a security professional's best friend.
See you next time.